The morning sun breaks over the ancient hills of southeastern Turkey, casting long shadows across stone pillars that should not exist. At Göbekli Tepe, archaeologist Klaus Schmidt kneels in the dirt, his weathered hands brushing away 12,000 years of accumulated earth from carved limestone that predates Stonehenge by 6 millennia. The massive T-shaped monoliths rise from the ground like tombstones of a forgotten world, their surfaces covered in intricate reliefs of animals that roamed the earth when humanity was supposed to be nothing more than scattered bands of hunter-gatherers. Schmidt pauses, staring at the impossible structure before him. According to everything mainstream archaeology teaches, the people who built this complex temple shouldn't have possessed the knowledge, tools, or social organisation necessary for such a monumental undertaking. They had no metal tools, no domesticated animals, no wheels, no written language. Yet somehow they quarried, carved, transported, and precisely arranged limestone blocks weighing up to 16 tons each, creating the world's first known temple complex at a time when human civilization was supposedly in its infancy. The implications are staggering. Göbekli Tepe wasn't built by primitive nomads scratching out a bare existence in the wilderness. It was constructed by a sophisticated society with advanced engineering knowledge, complex religious beliefs, and the organisational capacity to mobilise hundreds of workers for decades-long construction projects. But if such advanced civilisations existed 12,000 years ago, what happened to them? Why did they vanish without leaving any trace in the historical record? And most disturbing of all, what else have we forgotten about our own past? This is not an isolated mystery. Across the globe, archaeologists are uncovering evidence of advanced prehistoric civilisations that challenge everything we thought we knew about human history. At Gunung Padang in Indonesia, ground-penetrating radar reveals a massive pyramid complex buried beneath what was previously thought to be a natural hill. Carbon dating of organic material found between the artificial stone layers suggests construction began 27,000 years ago, during the last ice age, when mainstream archaeology insists humans were incapable of monumental architecture. In Turkey's underground city of Derinkuyu, 18 levels of precisely carved chambers descend 300 feet into solid rock, complete with ventilation systems, water supplies, and defensive mechanisms sophisticated enough to shelter 20,000 people for months at a time. The city shows clear signs of advanced engineering knowledge, yet no one knows who built it or when. Local legends attribute its construction to a time before memory itself. Off the coast of Japan, the Yonaguni monument rises from the ocean floor like a drowned city. Its terraced pyramids, straight walls, and right-angled corners bear all the hallmarks of artificial construction, yet they lie beneath waters that haven't been dry land for 12,000 years. Marine archaeologist Masaki Kimura has spent decades studying the structure, convinced it represents the remains of an advanced civilization that flourished when sea levels were hundreds of feet lower than today. The pattern repeats across continents and cultures. In Peru, the precision-cut stone blocks of Sacsayhuaman fit together so perfectly that a knife blade cannot slip between them, despite some weighing over 100 tons. In Egypt, the Great Pyramid of Giza demonstrates mathematical and astronomical knowledge that wasn't supposed to exist for millennia after its construction. In Cambodia, Angkor Wat's layout precisely mirrors the constellation Draco as it appeared 11,500 years ago, not when the temple was built, but when some unknown civilization may have first conceived its design. Each discovery forces the same uncomfortable question. If advanced civilizations existed in our distant past, why don't we remember them? The answer may lie in a phenomenon that archaeologists are only beginning to understand: the systematic erasure of human knowledge that occurs when civilizations collapse. Graham Hancock, the controversial author of Fingerprints of the Gods, has spent decades arguing that mainstream archaeology is engaged in a deliberate cover-up of evidence for advanced prehistoric civilizations. His work, dismissed by academic institutions as pseudo-archaeology, points to a global pattern of sophisticated structures, advanced technologies, and shared mythologies that suggest a worldwide civilization existed during the last ice age. The archaeological establishment's response has been swift and brutal. Hancock's theories are ridiculed in academic journals, his speaking engagements are protested, and his books are banned from university reading lists. The message is clear: questioning the established timeline of human development is not just wrong, it's heretical. But the evidence continues to accumulate. Satellite imagery reveals thousands of previously unknown archaeological sites hidden beneath jungle canopies and desert sands. LiDAR technology penetrates dense vegetation to map lost cities with populations in the hundreds of thousands. Ground-penetrating radar uncovers vast underground complexes that dwarf anything in the modern world. In the Amazon rainforest, researchers have discovered the remnants of sophisticated urban centres that housed millions of people. These cities featured advanced water management systems, road networks spanning hundreds of miles, and agricultural techniques that actually improve soil fertility over time. Yet they vanished so completely that early European explorers found only pristine wilderness, inhabited by scattered tribes with no memory of the great civilizations their ancestors had built. The Maya provide perhaps the most haunting example of civilizational amnesia. At the height of their classical period, they built cities larger than London, developed the concept of zero independently of Asia, and created astronomical calendars more accurate than those used in medieval Europe. Their mathematical and scientific achievements rivaled those of ancient Greece and Rome. Then, sometime around 900 AD, they simply walked away from their cities and returned to subsistence farming in the jungle. When Spanish conquistadors arrived 600 years later, they found Maya descendants living in simple thatched huts, using stone tools and practicing slash-and-burn agriculture. The great pyramids and palaces of their ancestors had been swallowed by the jungle, their advanced knowledge forgotten, their achievements reduced to incomprehensible myths about gods and giants who once ruled the earth. This pattern of forgetting is not unique to the Maya. Throughout history, human civilizations have demonstrated a terrifying capacity to lose their own technological and cultural achievements within a few generations of collapse. The fall of Rome left medieval Europeans unable to build the roads, aqueducts, and massive concrete structures their ancestors had constructed centuries earlier. The Bronze Age collapse, around 1200 BC, wiped out entire writing systems, leaving later generations unable to read their own history. But what if the process goes deeper than we realize? What if our own civilization, despite all its apparent permanence and technological sophistication, is itself built on the forgotten ruins of previous advanced societies? What if the prehistoric primitive peoples discovered by early anthropologists were not humanity in its original state, but the survivors of civilizational collapses so complete that they erased almost all traces of what came before? The possibility becomes more disturbing when we examine how quickly modern knowledge can disappear. The blueprints for the Saturn V rocket that carried humans to the moon have been lost. The craftsmen who knew how to work with certain materials used in stealth aircraft have retired without passing on their knowledge. Entire programming languages become obsolete within decades, their code unreadable to newer generations of developers. If a highly interconnected, digitally documented civilization can lose critical knowledge within a single human lifetime, how much more vulnerable were societies that relied on oral tradition and manual skills passed from master to apprentice? How many times has humanity climbed the ladder of civilization, only to fall back into darkness and begin the ascent again with no memory of previous attempts? The archaeological evidence suggests the answer may be far more often than we dare imagine. Beneath every ancient site archaeologists excavate, they find older sites. Beneath those, older still. Each layer reveals evidence of greater sophistication, more advanced knowledge, and more puzzling achievements. It's as if human civilization has been playing an endless game of snakes and ladders, climbing towards some unknown goal, only to slide back to the beginning and start again. At Jericho, archaeologists have found 26 successive layers of habitation, stretching back 11,000 years. Each represents a complete civilization with its own architecture, technology, and culture. Most left no written records, no names, no memory of their achievements beyond the silent testimony of their ruins. This pattern of cyclical rise and fall may explain the most puzzling aspect of human history: why advanced knowledge and sophisticated technology seem to appear fully formed in the archaeological record without any evidence of gradual development. The wheel, writing, metallurgy, mathematics, astronomy, all seem to emerge simultaneously across different regions of the world, as if some global civilization suddenly shared its knowledge with scattered survivors before disappearing forever. But if this is true, if advanced civilizations have risen and fallen repeatedly throughout human history, then we must confront an even more disturbing possibility. The myths and legends that every culture on Earth preserves may not be fantasy at all, but the fragmented memories of real events, real people, and real civilizations whose achievements were so far beyond their successors' comprehension that they could only be remembered as the deeds of gods. The flood stories found in over 500 cultures worldwide may record an actual global catastrophe that destroyed a worldwide civilization. The legends of giants, flying machines, and magical technologies may be garbled accounts of advanced peoples whose science appeared miraculous to later generations. The detailed descriptions of previous worlds and cosmic cycles found in Hindu, Maya, and other ancient texts may be historical documents disguised as mythology. If so, then we are not the first technological civilization to arise on this planet. We may not even be the second or third. We may be merely the latest in a long line of advanced societies, each convinced of its own uniqueness and permanence, each destined to follow the same trajectory from primitive beginnings, through technological mastery, to ultimate collapse and forgetting. The archaeological nightmare is not just that we have forgotten our past, it's that the pattern of forgetting may be built into the very nature of human civilization itself. Every time we reach a certain level of complexity and sophistication, something goes wrong. Wars break out, climates change, resources are exhausted, knowledge is lost. The survivors return to simpler ways of life, and the cycle begins again. But now, for the first time in human history, we may have developed technologies that could break this cycle, or make its final iteration complete. We have created artificial intelligence, genetic engineering, and digital storage systems that could preserve human knowledge indefinitely. We have also created nuclear weapons, environmental destruction, and social media algorithms that could erase civilization more thoroughly than any previous collapse. The question is no longer whether advanced civilizations existed before us and vanished without a trace. The archaeological evidence makes that virtually certain. The question is whether we will learn from their fate or repeat it, whether we will break the cycle of forgetting or become another lost civilization whose achievements future archaeologists will struggle to explain. But to answer that question, we must first understand how the process of civilizational amnesia works, how entire societies can lose not just their knowledge and technology, but their very memory of having possessed them at all. The year is 1200 BC, and across the Mediterranean world cities are burning. In the space of a single generation, the greatest civilizations of the Bronze Age, the Mycenaeans of Greece, the Hittites of Anatolia, the great trading cities of the Levant simply vanish from history. Palaces are abandoned, trade networks collapse, and writing systems disappear so completely that it will take archaeologists 3,000 years to decipher them again. This is the Bronze Age collapse, one of history's most dramatic examples of civilizational amnesia. Within 50 years, the complex societies that had dominated the Eastern Mediterranean for centuries were reduced to scattered tribes of subsistence farmers who had no memory of their ancestors' achievements. The Linear B script used by Mycenaean scribes to record their sophisticated palace economies became completely forgotten. The advanced metallurgy that had defined the age was lost, forcing survivors to make do with inferior iron tools. Even the names of their gods and heroes survived only as dim legends passed down through oral tradition. What makes this collapse particularly haunting is how thoroughly it erased its own causes. We know that these civilizations fell, but we have almost no contemporary records explaining why. The palace archives that might have documented the crisis were either destroyed or simply abandoned, their clay tablets left to bake in fires that consumed the buildings around them. The result is a historical mystery that continues to baffle scholars today. How did such advanced societies simply forget themselves out of existence? The answer lies in understanding a phenomenon that repeats throughout human history with terrifying regularity: the systematic erosion of cultural memory that follows civilizational collapse. When complex societies break down, they don't just lose their political unity or economic systems, they lose their ability to remember what they once were. Joseph Tainter, author of The Collapse of Complex Societies, has spent decades studying this process. His research reveals a consistent pattern. As civilizations grow more complex, they require increasingly sophisticated systems to maintain themselves. Administrative bureaucracies multiply, technological specialization increases, social stratification becomes more elaborate. Eventually, the energy required to maintain this complexity exceeds the society's ability to generate it, and the entire system begins to break down. But the breakdown isn't just economic or political, it's cognitive. The knowledge systems that sustain complex civilizations are incredibly fragile because they depend on continuous transmission from generation to generation. When that transmission is interrupted even briefly, centuries of accumulated wisdom can vanish forever. Consider what happened to Europe after the fall of Rome. The Western Roman Empire had developed concrete that was stronger and more durable than anything produced until the 20th century. Their engineers built roads, aqueducts, and massive domed structures that represented the pinnacle of ancient technology. Their legal system, administrative practices, and urban planning methods had evolved over centuries of continuous refinement. Yet within 200 years of Rome's collapse, medieval Europeans had forgotten how to make Roman concrete. They couldn't build structures comparable to the Pantheon or the great aqueducts. They were unable to maintain the road system that had connected the empire, and many Roman cities shrank to small towns clustered around the ruins of buildings they could no longer construct or properly maintain. The loss wasn't just technological, it was conceptual. Medieval scholars could read Latin, but they had lost the intellectual framework that made Roman engineering possible. They no longer understood the mathematical principles behind arch construction, the hydraulic systems that powered Roman fountains, or the surveying techniques that had laid out perfectly straight roads across thousands of miles of varied terrain. This wasn't simple decay through neglect, it was active forgetting, a systematic loss of knowledge that occurred because the social institutions responsible for preserving and transmitting technical expertise had collapsed. The guild system that trained Roman engineers dissolved. The schools that taught mathematics and natural philosophy closed. The libraries that contained technical manuals were abandoned or destroyed. Within a few generations, knowledge that had taken centuries to develop was as lost as if it had never existed. The pattern repeats across cultures and continents with disturbing consistency. The Maya civilization of Central America provides perhaps the most dramatic example of civilizational amnesia in the historical record. At their peak during the classical period, from approximately 200 to 900 AD, the Maya had developed one of the world's most sophisticated writing systems, containing over 800 distinct glyphs capable of expressing complex abstract concepts. Their mathematicians had independently invented the concept of zero and developed positional notation systems that allowed them to perform calculations involving numbers in the millions. Their astronomers created calendars more accurate than those used in medieval Europe, tracking the movements of Venus with an error of only 2 hours over a period of 500 years. They built cities like Tikal and Calakmul, with populations exceeding 100,000 people, connected by raised stone causeways that stretched for dozens of miles through dense jungle. Then, sometime around 900 AD, they walked away from it all. The great cities were abandoned so suddenly that archaeologists find half-finished construction projects and domestic artifacts left exactly where their owners had placed them. The complex writing system fell out of use so completely that when Spanish conquistadors arrived 600 years later, they found Maya descendants who could not read the inscriptions carved on their ancestors' monuments. The Spanish priest Diego de Landa, writing in the 16th century, described his encounters with Maya peoples who lived in simple thatched huts and practiced basic agriculture, showing no awareness that their ancestors had built some of the greatest cities in the pre-Columbian Americas. When shown the hieroglyphic inscriptions at sites like Chichen Itza, they could only repeat vague legends about gods and giants who had once ruled the earth. But perhaps the most chilling aspect of a Maya civilizational amnesia is how completely it extended to practical knowledge. The classic Maya had developed sophisticated water management systems, including reservoirs, canals, and filtration systems that allowed their cities to thrive in regions that modern settlements find barely habitable. They had created agricultural techniques, including raised field systems and forest gardens that actually improved soil fertility over time. All of this knowledge was lost. The Maya peoples encountered by the Spanish were practicing slash-and-burn agriculture that depleted the soil and supported only a fraction of the population their ancestors had sustained. They had no memory of their forebears' engineering techniques, mathematical achievements, or astronomical observations. In the space of a few centuries, one of the world's most advanced civilizations had been reduced to subsistence-level existence, with no conscious awareness of what had been lost. The mechanism of this forgetting becomes clear when we examine how complex knowledge is actually preserved and transmitted in human societies. Contrary to popular belief, the vast majority of technical and cultural knowledge is never written down. It exists in the minds of specialists, craftsmen, engineers, administrators, priests, who pass it on through direct instruction and apprenticeship. When these specialist classes disappear, either through war, disease, economic collapse, or social upheaval, their knowledge disappears with them. This is particularly true for the most advanced and specialized forms of knowledge, which are typically concentrated in the smallest number of practitioners. The more sophisticated a technology or intellectual system, the more vulnerable it is to complete loss if the chain of transmission is broken. The Library of Alexandria provides a perfect example of this vulnerability. For nearly 700 years, it served as the intellectual center of the ancient world, housing perhaps 400,000 scrolls containing the accumulated knowledge of Greek, Egyptian, and Near Eastern civilizations. Scholars from across the Mediterranean world came to study there, and its librarians actively collected texts from every corner of the known world. Yet the library's destruction, whether through Christian riots, Arab conquest, or simple neglect, remains disputed, didn't just eliminate a collection of books. It severed the intellectual networks that had made the library's knowledge meaningful and useful. The mathematical works of Archimedes, the geographical studies of Eratosthenes, the engineering treatises of Hero of Alexandria. These weren't just lost texts, they were entire traditions of inquiry that died with the institutions that had sustained them. By the time European scholars rediscovered many of these works during the Renaissance, they had to essentially reinvent the intellectual frameworks necessary to understand them. It took centuries to rebuild the mathematical and scientific knowledge that had been common among Alexandrian scholars in the 2nd century AD. This pattern of institutional collapse leading to knowledge loss helps explain some of the most puzzling aspects of ancient technology. The Damascus steel produced by medieval Middle Eastern smiths was renowned throughout the world for its strength and distinctive watered pattern. The technique was so closely guarded and specialized that only a few master smiths in each generation possessed it. When the last of these craftsmen died without passing on their knowledge, the secret of Damascus steel was lost forever. Similarly, Greek fire, the incendiary weapon that gave the Byzantine Empire a decisive military advantage for centuries, was known only to a small group of military engineers who swore oaths of secrecy. When the empire fell and these specialists were killed or dispersed, the formula vanished so completely that modern chemists can only speculate about its composition. But the loss of technical knowledge is only part of the forgetting process. More fundamentally, collapsing civilizations lose their ability to understand their own achievements. The cognitive frameworks that make complex knowledge meaningful, the mathematical concepts, philosophical systems, and cultural assumptions that give specialized knowledge its context, disappear along with the institutions that maintained them. This explains why post-collapse societies don't just lose specific technologies, they lose the ability to conceive that such technologies ever existed. Medieval Europeans didn't think of themselves as having forgotten how to build Roman-style buildings. They simply couldn't imagine that such construction was possible with available materials and techniques. The limitations they experienced seemed natural and unchangeable, not the result of lost knowledge. The Easter Island civilization provides a particularly haunting example of this process. Archaeological evidence reveals that the island once supported a complex society of 15,000 to 20,000 people who developed sophisticated statue carving techniques, complex social hierarchies, and a unique writing system called Rongorongo. By the time European explorers arrived in the 18th century, they found fewer than 3,000 inhabitants living in cave shelters and practicing basic subsistence agriculture. The Rongorongo script had been completely forgotten. The islanders could not read the wooden tablets covered with their ancestors' writing. They had no memory of how the massive Moai statues had been carved or transported, attributing their creation to supernatural forces. Most tragically, they had lost all knowledge of the sustainable resource management practices that had allowed their ancestors to thrive on an isolated island in the middle of the Pacific Ocean. The ecological collapse that had reduced Easter Island's population and complexity had also erased the accumulated wisdom that might have prevented it from happening again. This pattern of forgetting extends beyond individual civilizations to encompass entire technological traditions. The Antikythera mechanism, a complex bronze computer dating to the 1st century BC, demonstrates mechanical engineering capabilities that weren't matched again until clockmakers of the Renaissance developed similar gear systems 2,000 years later. The device could predict eclipses, track the positions of planets, and calculate the dates of Olympic Games with remarkable precision. Yet this extraordinary achievement appears to have been completely forgotten. No contemporary sources describe similar devices, and no subsequent ancient or medieval texts reference the principles behind its construction. The knowledge required to create such a sophisticated analog computer simply vanished from human memory until modern archaeologists recovered it from a shipwreck in 1901. The implications of this pattern are profoundly disturbing. If advanced technological knowledge can disappear so completely that later generations cannot even conceive of its existence, how much of human achievement has been lost without a trace? How many times has our species developed sophisticated solutions to fundamental problems, only to forget them during periods of crisis and collapse? The answer may lie in recognizing that civilizational memory operates on multiple levels simultaneously. There is the formal, institutional memory preserved in written records and official archives. There is the practical memory embedded in technologies, techniques, and social practices. And there is the mythological memory that preserves the emotional and spiritual significance of past achievements in the form of stories, legends, and religious beliefs. When civilizations collapse, these different forms of memory don't disappear at the same rate. Formal records are often the first to go, destroyed by war or abandoned when literacy declines. Practical knowledge may persist longer, passed down through craft traditions and folk practices. But mythological memory can survive for millennia. Encoding information about past achievements in forms so transformed by time and retelling that their historical origins become unrecognizable. This suggests that the flood myths found in cultures around the world may indeed preserve memories of real catastrophic events. The stories of golden ages and previous worlds found in Hindu, Greek, and Native American traditions may be garbled recollections of actual periods of greater technological and social sophistication. The legends of giants, flying machines, and magical technologies may be the mythologized remnants of advanced civilizations whose achievements exceeded their successors' ability to comprehend them literally. If this is true, then our own mythologies may be history books written in a language we have forgotten how to read. The gods and heroes of ancient legends may be distorted memories of real people whose knowledge and capabilities seem supernatural to later, less advanced societies. The detailed cosmologies and world cycles described in ancient texts may be attempts to preserve scientific and historical information in the only form likely to survive civilizational collapse: story. But this raises an even more troubling question. If human societies have repeatedly developed advanced knowledge and then lost it, what does this say about the stability of our own achievements? Are we living through just another cycle in an endless pattern of rise and fall, destined to become the subject of future myths, when our own civilization joins the archaeological record? The evidence suggests that we may indeed be more vulnerable to forgetting than we realize. Despite all our digital storage systems and global communications networks, critical knowledge continues to disappear with alarming regularity. The blueprints for the Apollo program have been lost. The techniques used to create certain specialized materials are known only to aging craftsmen who may take their knowledge to the grave. Entire programming languages become obsolete within decades, their code as unreadable to future generations as Linear B was to post-Bronze Age Greeks. More fundamentally, our increasingly specialized and interconnected technological systems may be even more fragile than those of previous civilizations. A Roman blacksmith could make his own tools and pass his knowledge to apprentices through direct instruction. A modern engineer requires a vast infrastructure of suppliers, manufacturers, educational institutions, and technological systems to function effectively. If that infrastructure breaks down, even temporarily, the knowledge it supports may be as vulnerable to loss as the sophisticated metallurgy of Damascus steel or the astronomical calculations of Maya astronomers. We may be building our own civilizational amnesia into the very systems we believe will preserve our achievements for posterity. But to understand how this process of forgetting might play out in our own time, we must first examine the mythological memory of previous collapses, the stories that may be all that remains of lost civilizations whose achievements were so far beyond their successors' comprehension that they could only be remembered as the deeds of gods. In the highlands of Peru, an elderly Quechua woman sits by her fire speaking words that have been passed down through her family for over 400 generations. She tells of Viracocha, the great teacher who emerged from Lake Titicaca to instruct her ancestors in the arts of civilization, agriculture, architecture, metallurgy, and astronomy. According to her story, Viracocha and his followers possessed knowledge that seemed magical to primitive humans. They could cut and move massive stones with ease, fly through the air in shining vehicles, and speak to people across vast distances without messengers. 10,000 miles away, in the remote villages of the Amazon basin, another indigenous elder recounts remarkably similar tales. His ancestors speak of sky beings who descended from the heavens to teach the first humans how to cultivate crops, build cities, and track the movements of celestial bodies. These beings possessed tools that could level mountains and create perfect stone structures without the laborious chipping and grinding that human craftsmen required. Half a world away in the mountains of Tibet, Buddhist monks preserve ancient texts that describe previous world ages when humanity possessed flying machines called vimanas, weapons that could destroy entire cities, and communication devices that allowed instant contact across continents. The Mahabharata, one of India's great epic poems, contains detailed descriptions of aerial battles fought with weapons that blazed like the sun and left the earth scorched and barren for years afterward. These stories, dismissed by mainstream academia as primitive mythology or religious fantasy, share striking similarities that become impossible to ignore when examined systematically. Across continents and cultures that had no contact with each other, human societies have preserved nearly identical accounts of previous ages when advanced beings possessed technologies that wouldn't be reinvented until the 20th century, or haven't been reinvented at all. The pattern becomes even more compelling when we examine the global distribution of flood myths. Over 500 distinct cultures around the world preserve detailed stories of a great deluge that destroyed a previous civilization. From the biblical account of Noah to the Mesopotamian epic of Gilgamesh, from Hindu texts describing the end of previous cosmic ages to Native American legends of world-destroying floods, these stories share consistent elements that suggest a common origin. In most versions, the flood is preceded by moral corruption and technological hubris on the part of an advanced civilization. The survivors are typically chosen for their righteousness or wisdom, and they preserve the knowledge necessary to rebuild civilization after the waters recede. The flood itself is often described as lasting for specific periods, 40 days and nights in Hebrew tradition, similar durations in Greek, Hindu, and American indigenous accounts. What makes these flood stories particularly intriguing is their remarkable consistency in describing the civilizations that were destroyed. The antediluvian world is consistently portrayed as possessing advanced technology, sophisticated architecture, and knowledge of sciences that their descendants would struggle to rediscover. The biblical account speaks of giants in the earth and mighty men of renown. Hindu texts describe previous ages when humans lived for thousands of years and possessed abilities that seem supernatural by modern standards. The Sumerian king list, one of humanity's oldest historical documents, records the reigns of rulers before the flood swept over the earth. These antediluvian kings are said to have ruled for impossibly long periods, some for tens of thousands of years. After the flood, the recorded reign lengths dropped dramatically to more human scales. Most scholars dismiss these lengthy reigns as mythological exaggeration. But what if they represent something else entirely? What if these impossibly long reigns reflect the extended lifespans and advanced medical knowledge of a previous technological civilization? What if the dramatic reduction in lifespan after the flood represents the loss of advanced life extension technologies during a global catastrophe? The pattern suggests that whoever compiled the Sumerian king list was working from records that preserved memories of a time when human civilization possessed capabilities that seemed impossible to later, less advanced societies. The Hindu concept of cosmic cycles provides perhaps the most sophisticated framework for understanding these patterns. According to texts like the Puranas and the Mahabharata, time moves in vast cycles called kalpas, each containing thousands of smaller cycles called yugas. During the Satya Yuga, or Golden Age, humans possess advanced spiritual and technological abilities, living in harmony with natural laws and cosmic principles. As the cycles progress through the Treta, Dvapara and Kali Yugas, human knowledge and capabilities gradually decline until civilization collapses and the cycle begins anew. These texts describe the Dvapara Yuga, the age immediately preceding our current Kali Yuga, as a time when humans possessed vimanas, or flying vehicles, along with weapons of mass destruction and communication technologies that allowed instantaneous contact across vast distances. The descriptions are remarkably specific, providing technical details about the construction and operation of these devices that read more like engineering manuals than mythological accounts. The Vaimanika Sastra, an ancient Sanskrit text, describes multiple types of flying vehicles with detailed specifications for their construction, fuel systems and navigational equipment. It includes drawings of aircraft that bear striking resemblances to modern helicopters, jets, and even spacecraft. While some scholars argue that these texts were compiled relatively recently, the technical knowledge they contain suggests access to information about aerodynamic principles that weren't understood by mainstream science until the 20th century. Similarly, the Mahabharata contains descriptions of weapons that sound disturbingly similar to modern nuclear devices. The Brahmastra is described as a weapon that blazed like 1,000 suns, and left the earth scorched and barren with trees withering and birds falling from the sky. Survivors of its use lost their hair and nails, and suffered from mysterious ailments that matched the symptoms of radiation poisoning. The text even describes decontamination procedures that mirror modern protocols for dealing with radioactive contamination. Survivors are instructed to wash thoroughly in running water and dispose of their clothing and possessions. For a supposedly primitive mythology, these accounts demonstrate remarkably sophisticated understanding of the effects of high-energy weapons on living organisms and the environment. But perhaps the most intriguing aspect of these ancient texts is their treatment of time itself. Modern physics has revealed that time is relative, that space and time are interconnected, and that matter and energy are equivalent, concepts that form the foundation of Einstein's theories of relativity. Yet these same concepts appear in ancient Hindu and Buddhist texts that predate Einstein by thousands of years. The Bhagavata Purana describes how time flows differently in different regions of the universe, with a single day in some realms equivalent to thousands of years on Earth. It speaks of the fundamental unity of matter, energy, space, and time in ways that seem to anticipate modern unified field theories. The Buddhist concept of interdependent origination suggests that all phenomena arise in dependence upon multiple causes and conditions, a view that closely parallels modern systems theory and quantum mechanics. These parallels become even more striking when we examine the mathematical concepts preserved in ancient texts. The Hindu concept of infinity, encoded in Sanskrit terms like Ananta and Purna, demonstrates sophisticated understanding of mathematical principles that weren't formally developed in Western mathematics until the 19th century. Ancient Indian mathematicians developed concepts of zero, infinity, and multiple orders of infinity that remained unknown to European scholars until relatively recent times. The precision of ancient astronomical knowledge provides additional evidence that previous civilizations possessed scientific capabilities far beyond what mainstream archaeology attributes to them. The Antikythera mechanism, recovered from a Roman shipwreck, demonstrates mechanical engineering and astronomical knowledge that wouldn't be matched again until the Renaissance. But the mechanism itself appears to be based on much older Greek astronomical models that may have originated in Babylonian or Egyptian sources. The Great Pyramid of Giza encodes mathematical relationships that suggest its builders possessed knowledge of advanced geometry, astronomy, and physics. Its dimensions incorporate the value of pi, the golden ratio, and precise astronomical alignments that account for the precession of the equinoxes, a 26,000-year cycle that requires centuries of careful observation to detect and calculate accurately. The The pyramid's internal chambers are aligned with specific stars and constellations as they appeared thousands of years before the structure was supposedly built, suggesting that its designers were working from much older astronomical records. The precision of these alignments exceeds what could be achieved with the tools and techniques that mainstream archaeology attributes to Old Kingdom Egypt. Similar patterns appear in megalithic sites around the world. Stonehenge's trilithons frame the sunrise and sunset at the solstices with extraordinary precision, requiring knowledge of astronomical cycles and engineering capabilities that supposedly didn't exist in Neolithic Britain. The stone circles of Nabta Playa in southern Egypt align with the heliacal rising of stars as they appeared 7,000 years ago, demonstrating that ancient peoples were tracking celestial movements with the accuracy of modern observatories. But perhaps the most compelling evidence for advanced ancient knowledge comes from the Aboriginal Australians, whose oral traditions preserve geological and astronomical information with stunning accuracy over periods that span tens of thousands of years. Dreamtime stories describe the formation of specific geographical features, the changing positions of stars, and the effects of sea level changes that occurred at the end of the last ice age. These stories encode precise information about events that occurred over 10,000 years ago, passed down through hundreds of generations with minimal distortion. They describe the flooding of coastal areas that can be verified through underwater archaeology, the formation of islands and peninsulas that match geological evidence, and the changing positions of celestial objects that align with astronomical calculations. The Aboriginal tradition demonstrates that sophisticated knowledge can be preserved through oral transmission over vast periods of time, but only when that knowledge is embedded in cultural practices that ensure its accurate transmission. The stories are not just entertainment or religious instruction. They serve as practical guides to navigation, resource management, and survival in challenging environments. This suggests that the mythologies preserved by cultures around the world may function similarly, as encoding systems that preserve technical and historical information in forms designed to survive civilizational collapse. The fantastic elements that cause modern scholars to dismiss these stories as primitive superstition may actually be mnemonic devices that help ensure accurate transmission across generations. The consistent presence of advanced technological concepts in ancient mythologies, from flying vehicles and devastating weapons to instantaneous communication and life extension techniques, may reflect memories of actual technologies that existed in previous ages. The gods and culture heroes described in these stories may be distorted memories of real people whose knowledge and capabilities seem supernatural to their less advanced successors. This interpretation gains support from the consistent patterns found in creation myths around the world. Most cultures preserve stories of previous worlds or ages that were destroyed by catastrophes, followed by the emergence of new civilizations from the survivors. These stories often describe the transmission of knowledge from advanced beings to primitive humans, usually in the context of teaching fundamental technologies like agriculture, metallurgy, and astronomy. The Mesopotamian stories of the Anunnaki, the Greek accounts of the Titans and Olympians, the Egyptian narratives of the Neteru, and the Mesoamerican legends of Quetzalcoatl and Viracocha all follow similar patterns. Advanced beings emerge from the sky, from across the sea, or from underground realms to instruct primitive humans in the arts of civilization. They establish great cities, construct massive monuments, and create institutions that will preserve their knowledge for future generations. Then, after completing their work, these culture heroes depart, promising to return at some future time when humanity needs their guidance again. The civilizations they establish flourish for a time, but eventually decline and fall, leaving only ruins and legends to mark their passing. What makes these stories particularly intriguing is their treatment of knowledge transmission. The culture heroes don't just give humans technology. They establish schools, priesthoods, and secret societies dedicated to preserving and transmitting advanced knowledge. They create mystery schools that guard esoteric wisdom, build monuments that encode astronomical and mathematical principles, and establish oral traditions that preserve crucial information across generations. This suggests that previous advanced civilizations may have anticipated their own collapse and deliberately created systems to preserve their most important knowledge through the coming Dark Age. The myths and legends that survive today may be the remnants of these preservation systems, garbled and distorted by time, but still containing recoverable information about the achievements of our predecessors. The implications of this possibility are profound. If human mythology preserves memories of previous advanced civilizations, then our own technological achievements may not be unprecedented. We may be rediscovering knowledge that was once commonplace, following pathways that were mapped out by previous explorers of the possible. But this raises an even more disturbing question. If previous civilizations possessed advanced technology and still collapsed into oblivion, what does this suggest about the fate of our own society? Are we approaching the same cliff that claimed our predecessors, or have we learned enough from their mythologized warnings to avoid repeating their mistakes? The answer may depend on whether we can learn to read the true message encoded in our oldest stories, not as primitive fantasies about gods and heroes, but as urgent warnings from the future about the dangers that await any civilization that reaches a certain level of technological capability without developing the wisdom to use it responsibly. But to understand what those warnings might be telling us, we must first examine the physical evidence that these advanced civilizations left behind, artifacts so impossible by conventional archaeological standards that their very existence challenges everything we think we know about the history of human technological development. The crystal-clear waters off the Greek island of Antikythera reveal their secrets reluctantly. In 1901, sponge divers working the treacherous currents discovered the remnants of an ancient Roman shipwreck scattered across the seafloor 60 meters below the surface. Among the bronze statues, marble sculptures, and ceramic vessels they recovered lay a corroded lump of bronze that would sit ignored in storage at the National Archaeological Museum of Athens for decades. It wasn't until 1951 that archaeologist Valerios Stais noticed something extraordinary about this unremarkable-looking artifact. As the corrosion was carefully cleaned away, intricate bronze gears began to emerge from within the mechanism. Dozens of precisely cut wheels, differentials, and calibrated dials arranged in a configuration that seemed impossible for a device dating to the 1st century BC. The Antikythera mechanism, as it came to be known, represents one of the most stunning technological anachronisms ever discovered. X-ray analysis has revealed an analog computer of breathtaking sophistication, a mechanical device capable of predicting eclipses, tracking the positions of the sun, moon, and planets, calculating the dates of Olympic Games, and following complex astronomical cycles with extraordinary accuracy. The bronze gears are cut with a precision that wouldn't be matched again until the development of sophisticated clockmaking techniques during the Renaissance. The device incorporates differential gear systems that weren't supposed to be invented until the 17th century. Its design demonstrates knowledge of advanced mathematics, astronomy, and mechanical engineering that orthodox archaeology insists didn't exist in the ancient world. Derek de Solla Price, the Yale University historian who spent decades studying the mechanism, concluded that its technology was so advanced that it is like finding a jet plane in the tomb of King Tutankhamun. The device's complexity suggests that ancient Greek civilization had developed mechanical engineering capabilities that were completely forgotten after the fall of the Roman Empire, not to be rediscovered until European clockmakers began creating similar mechanisms 2,000 years later. But the Antikythera mechanism is far from the only artifact that challenges our understanding of ancient technological capabilities. Across the world, archaeologists continue to uncover objects that seem to have been created by civilizations possessing knowledge and tools that supposedly didn't exist for millennia after their construction. High in the Bolivian Altiplano, at an elevation of nearly 13,000 feet above sea level, lies the ancient complex of Pumapunku. Here, scattered across the windswept plateau, are hundreds of precisely cut stone blocks that demonstrate machining tolerances achievable only with modern equipment. The red sandstone and andesite blocks are cut with such precision that they fit together with gaps measured in fractions of millimeters, tolerances that challenge even contemporary stone-cutting technology. The blocks themselves defy explanation by conventional archaeological methods. Many weigh over 100 tons and would require massive cranes and sophisticated transportation systems to move and position. Yet mainstream archaeology dates the complex to approximately 1,500 years ago, when the Tiwanaku civilization supposedly possessed only bronze tools, rope, and human labor for construction projects. More puzzling still are the complex geometric patterns cut into many of the blocks. The surfaces are machined to mathematical perfection, with right angles precise to within fractions of a degree, and surfaces flat to tolerances measured in millimeters across spans of several meters. The blocks contain intricate interlocking joints, H-shaped cuts, and precisely drilled holes that would challenge modern stone-cutting equipment. Engineer Christopher Dunn, who has spent decades analysing the precision of ancient stonework, argues that the tolerances achieved at Pumapunku exceed what could be accomplished with any known ancient technology. The surfaces show no tool marks, no evidence of the gradual shaping process that would be expected from bronze or stone tools. Instead, they appear to have been cut using techniques that remove material uniformly across entire surfaces, methods that require sophisticated machinery and diamond-tipped cutting tools. The precision extends to the internal structure of the blocks themselves. Core samples reveal that the stone has been cut through complex internal geometries that would be impossible to achieve without advanced drilling and cutting equipment. Some blocks contain perfectly round holes drilled through their centres, with diameters that remain constant to within fractions of millimeters along their entire length. Similar precision appears in megalithic sites around the world. The Great Pyramid of Giza contains chambers and passages cut with tolerances that exceed modern construction standards. The internal chambers are positioned with astronomical precision that accounts for the precession of the equinoxes over thousands of years. The pyramid's base is level to within just 2 centimeters across its entire footprint, a degree of accuracy that challenges contemporary surveying techniques. The blocks used in the pyramid's construction weigh up to 15 tons each and are fitted together with gaps so tight that a knife blade cannot be inserted between them. The precision extends to the pyramid's internal structure, where shafts are drilled through solid limestone at precise angles calculated to align with specific stars as they appeared in the ancient sky. But perhaps even more puzzling than the pyramid's construction are the artifacts found within and around it. In 1898, British archaeologist William Flinders Petrie discovered what appeared to be sophisticated machine tools in the ruins of ancient Egyptian workshops. Among these was a granite bowl turned with such precision that its walls maintained uniform thickness to within thousandths of an inch, a tolerance that would be difficult to achieve even with modern lathes. Petrie also found evidence of sawing and drilling techniques that seemed to remove material faster than would be possible, with the copper tools supposedly available to ancient Egyptian craftsmen. Granite cores recovered from drilling operations showed spiral grooves that indicated feed rates exceeding what could be achieved by hand-operated equipment. The evidence suggested that ancient Egyptian workers possessed power tools capable of cutting and shaping the hardest stones with industrial efficiency. The mystery deepens when we examine other Egyptian artifacts that demonstrate impossible precision. The red granite obelisks that stand in temples and public squares around the world were quarried, carved and transported using techniques that remain mysterious today. These monolithic stones, some weighing over 300 tons, were shaped with such accuracy that their surfaces remained flat to within millimeters across lengths of 30 meters or more. The hieroglyphic inscriptions carved into these obelisks show precision that exceeds what could be achieved by hand tools. The depth of cut remains uniform across entire surfaces, the angles are mathematically perfect, and the spacing demonstrates the use of sophisticated measuring and layout techniques. Modern attempts to recreate similar precision using reconstructed ancient tools have failed to achieve comparable results. But Egypt is not unique in preserving evidence of advanced ancient technology. In Peru, the fortress of Sacsayhuaman demonstrates stone-cutting techniques that rival anything found in Egypt. The massive limestone blocks that form the complex's walls are fitted together with such precision that mortar was unnecessary. Some blocks weigh over 200 tons and are shaped with complex curves and angles that would be challenging to achieve even with modern equipment. The blocks show evidence of a cutting technique that leaves surfaces with a vitrified glass-like finish, as if the stone had been subjected to extreme heat that partially melted its surface. This finish appears on internal surfaces that would have been inaccessible during the fitting process, suggesting that the vitrification occurred before the blocks were positioned. Similar evidence of high-temperature stoneworking appears at other Peruvian sites. At Ollantaytambo, massive granite blocks show signs of having been softened and moulded like clay before hardening into their final positions. The blocks conform to irregular surface contours in ways that would be impossible if they had been carved and fitted using conventional techniques. The precision of these ancient construction techniques becomes even more remarkable when we consider the materials involved. The builders of these sites were working with some of the hardest stones on Earth: granite, diorite, and basalt that rank near the top of the Mohs hardness scale. These materials can only be effectively worked with diamond-tipped tools or other extremely hard cutting implements that weren't supposed to exist in the ancient world. Yet evidence of advanced metallurgy appears throughout the archaeological record. In India, the Delhi Iron Pillar has stood exposed to the elements for over 1600 years without showing significant signs of rust. The pillar is composed of an iron alloy that demonstrates metallurgical knowledge more advanced than anything available to medieval Indian smiths. Its corrosion resistance exceeds that of many modern steel alloys. The pillar's construction required techniques for producing large quantities of high-purity iron that weren't developed in Europe until the Industrial Revolution. The metal shows evidence of sophisticated alloying and heat treatment processes that suggest access to advanced furnace technology and chemical knowledge that orthodox history claims didn't exist in ancient India. Similar anomalies appear in the archaeological record of other ancient civilizations. Roman concrete, used in structures like the Pantheon and harbour installations throughout the Mediterranean, demonstrates chemical properties that weren't understood again until the 20th century. The concrete actually grows stronger over time through reaction with seawater, incorporating volcanic ash in ways that create self-healing properties when cracks develop. The Romans also developed lead pipes and fixtures that show evidence of sophisticated understanding of hydraulic engineering. Their aqueduct systems incorporated pressure-resistant joints, flow regulation mechanisms, and distribution networks that required advanced knowledge of fluid dynamics and material science. But perhaps the most intriguing artifacts are those that suggest knowledge of principles not officially discovered until much later periods. In Iraq, archaeologists have discovered what appear to be galvanic cells dating to the Parthian period, ceramic jars containing copper cylinders and iron rods that produce electrical current when filled with acidic solutions. These Baghdad batteries demonstrate understanding of electrochemical principles that weren't formally described until Alessandro Volta's work in the 18th century. The purpose of these devices remains unclear, but their construction suggests that ancient Mesopotamian craftsmen possessed practical knowledge of electrical phenomena. Some researchers have speculated that they were used for electroplating gold and silver objects, a technique that would require sophisticated understanding of both chemistry and electrical principles. Similar technological anomalies appear in ancient Egyptian art and architecture. The temple complex at Dendera contains carved reliefs that appear to depict electrical devices, bulbous objects connected to braided cables and supported by pillar-like insulators. The images show human figures manipulating these devices in ways that suggest they were functional equipment, rather than purely symbolic representations. The Dendera reliefs include detailed drawings of what appear to be filaments or electrodes within the bulbous objects, along with serpentine forms that may represent electrical discharges. The entire complex of images suggests that ancient Egyptian priests possessed some form of electrical lighting technology that allowed them to illuminate the interior chambers of their temples without the smoke and soot that would result from torch or oil lamp illumination. The precision of Egyptian stone carving also suggests access to advanced tools that haven't been identified in the archaeological record. The intricate hieroglyphic inscriptions found throughout Egyptian temples and tombs demonstrate uniformity of depth, angle, and spacing that would be difficult to achieve without mechanical guidance systems. The carving shows no evidence of the gradual correction process that would be expected from handwork, but instead appears to have been executed in single passes, with tools that maintained perfect control throughout the cutting process. These technological anomalies become even more puzzling when we consider their sudden disappearance from the historical record. The advanced concrete formulations used by Roman engineers were completely forgotten after the empire's collapse, not to be rediscovered until modern chemical analysis revealed their sophisticated composition. The precision stone-cutting techniques evident at sites like Pumapunku and Sacsayhuaman left no trace in the technological traditions of later Andean civilizations. The pattern suggests that these advanced technologies were not the products of gradual development within known historical civilizations, but rather the remnants of earlier technological traditions that were already ancient when the societies we know about inherited them. The builders of the Great Pyramid may have been working from plans and techniques developed by predecessors whose achievements were already legendary in their own time. This interpretation gained support from the mythological traditions associated with many of these sites. Local legends consistently attribute their construction to gods, giants, or culture heroes who possess supernatural abilities. The Incas claimed that Sacsayhuamán was built by Viracocha and his followers using techniques that could soften stone like clay. Egyptian texts attribute the construction of the Great Pyramid to Thoth, the god of wisdom and technology, who supposedly possessed knowledge of advanced sciences. These legends may preserve memories of actual technological capabilities that seemed magical to later, less advanced civilizations. The descriptions of stone-softening techniques, precision-cutting tools, and massive transportation systems found in ancient texts may be attempts to describe real technologies using the limited vocabulary available to societies that had lost the knowledge necessary to understand them. But the implications of these impossible artifacts extend far beyond simple technological mysteries. If ancient civilizations possessed advanced knowledge and sophisticated tools that were subsequently lost, what does this tell us about the stability of technological development? Are we rediscovering capabilities that were once commonplace, following a path that has been traveled before by predecessors whose achievements we can barely comprehend? The answer may lie not in individual artifacts or isolated sites, but in recognizing the global pattern of technological anomalies that challenges our fundamental assumptions about human history. From the mechanical computers of ancient Greece to the precision stonework of Peru, from the advanced metallurgy of India to the electrical devices of Mesopotamia, the evidence suggests that our ancestors possessed knowledge and capabilities that were systematically lost during periods of civilizational collapse. But if this is true, then we must confront an even more disturbing possibility. The technological achievements we take pride in may be nothing more than rediscoveries of ancient knowledge, repetitions of a cycle that has played out many times before. We may be approaching the same crossroads that faced our predecessors, the moment when advanced technology must be balanced against the wisdom to use it responsibly, or face the same fate that befell the mysterious civilizations whose impossible artifacts still puzzle us today. The question is no longer whether advanced ancient civilizations existed, but what happened to them, and whether we can learn from their fate before it becomes our own. In the sterile corridors of Oxford University's Faculty of Philosophy, philosopher Nick Bostrom sits before his computer screen, typing equations that will fundamentally challenge our understanding of reality itself. The year is 2003. And Bostrom is developing what will become known as the simulation hypothesis, a rigorous mathematical argument suggesting that we are almost certainly living inside a computer simulation created by a more advanced civilization. His reasoning follows an elegant logical progression. Any civilization that reaches technological maturity will likely develop enormous computational power, far exceeding what would be necessary to simulate the detailed experiences of billions of conscious beings. If they choose to run such simulations, they could create thousands or millions of simulated worlds, each containing entire histories of civilizations that believe themselves to be real. The mathematics are stark and unsettling. If advanced civilizations typically run many ancestor simulations, then the vast majority of conscious beings like ourselves would be simulated rather than original. The odds that we happen to be among the tiny minority of real beings, rather than among the overwhelming majority of simulated ones, become vanishingly small. By Bostrom's calculations, we should assign a very high probability to the possibility that our entire reality is artificial. Elon Musk, speaking at the Code Conference in 2016, put the odds even more bluntly. The chance that we're in base reality is billions to one against. His reasoning echoed Bostrom's logic but added a technological perspective informed by the rapid advancement of virtual reality and artificial intelligence. If video games had evolved from simple two-dimensional graphics to photorealistic three-dimensional worlds in just 40 years, Musk argued, then it seemed inevitable that eventually simulations would become indistinguishable from reality. But what neither Bostrom nor Musk initially considered was how this hypothesis might explain the archaeological mysteries that have puzzled researchers for decades. If we are living in a simulation created by an advanced civilization, then the impossible artifacts scattered throughout our world might not be anomalies at all. They might be clues deliberately embedded in our simulated reality by its creators. The possibility becomes more intriguing when we consider what such a simulation might be designed to accomplish. Rather than being mere entertainment or academic exercise, our reality might serve as a form of digital archaeology, a detailed reconstruction of the civilization that created it, designed to preserve their history and perhaps help them understand their own past. Dr. Rich Terrell, a scientist at NASA's Jet Propulsion Laboratory, has argued that quantum mechanics itself provides evidence for the simulation hypothesis. At the quantum level, our universe behaves remarkably like a computer simulation. Information appears to be pixelated at the smallest scales, with the Planck length representing a kind of fundamental resolution limit below which space itself becomes undefined. Time similarly appears to be quantized, proceeding in discrete steps rather than flowing continuously. Most tellingly, quantum mechanics suggests that reality only becomes definite when it is observed or measured. Until that moment, quantum systems exist in superposition, multiple potential states simultaneously. This is exactly how a sophisticated computer simulation would operate, calculating only those details that are actually needed, while leaving unobserved aspects in undefined states to save computational resources. The observer effect in quantum mechanics may be nothing more than the simulation's rendering system, updating the detailed state of reality only when conscious beings direct their attention to specific phenomena. Like a video game that renders only the portions of its virtual world that players can currently see, our universe might be optimizing its computational load by maintaining detailed reality only where conscious observation requires it. This interpretation of quantum mechanics suggests that our reality operates according to principles that would be natural for a computer simulation, but deeply mysterious for a physical universe. The fact that information appears to be more fundamental than matter or energy, as suggested by theories like John Wheeler's it from bit hypothesis, becomes much more comprehensible if our entire reality is ultimately computational rather than physical. But if we accept the possibility that we're living in a simulation, we must ask, who created it and why? The archaeological evidence suggests a disturbing answer. The impossible artifacts scattered throughout our world, from the Antikythera mechanism to the precision stonework of Puma Punku, may be digital reconstructions of technologies that actually existed in the civilization that created our simulation. This would explain why these artifacts seem so far advanced compared to their supposed historical contexts. They weren't created by the primitive civilizations that orthodox archaeology attributes them to. They are perfect digital reproductions of technologies that existed in the real world of our simulators, a world that may have achieved technological capabilities far beyond our current understanding. The precision of these artifacts now makes perfect sense. In a simulation, there's no difference between reproducing something with millimeter tolerances or micrometer tolerances. Both require the same computational effort. The impossible precision of ancient stonework isn't impossible at all if it represents the perfect digital reproduction of real structures built by a civilization with advanced manufacturing capabilities. This interpretation also explains why these advanced technologies appear suddenly in the archaeological record without any evidence of gradual development. They weren't developed by the civilizations we associate with them. They are artifacts from the simulator civilization, inserted into our reconstructed history to preserve the memory of their actual achievements. The mythological traditions that attribute these structures to gods, giants, and culture heroes may be remarkably accurate. The gods, described in ancient texts, might be digital representations of the actual people who created our simulation. Members of an advanced civilization whose knowledge and capabilities seem supernatural to us because we are seeing them through the limited perspective of their simulated reconstruction. This possibility gains support from the consistent patterns found in creation myths worldwide. Almost universally, these stories describe advanced beings who emerge from elsewhere, from the sky, from across the sea, from other dimensions, to establish civilization and then depart again. This is exactly what we might expect if our reality were created by beings who existed outside our simulated universe, who programmed our world with the history of their own civilization, and who then stepped back to observe how that history would unfold. The flood myths found in over 500 cultures worldwide might preserve memories of the actual catastrophe that destroyed the simulator civilization. If they were facing extinction through war, environmental collapse, resource depletion, or some other existential threat, they might have had just enough time to create detailed simulations of their world before their physical reality was destroyed. In this interpretation, we're not just random simulated beings. We are the digital descendants of a real civilization that faced destruction and chose to preserve itself through simulation rather than accept oblivion. Our entire reality exists as a monument to their achievements, and perhaps as a warning about the fate that awaits any civilization that reaches a certain level of technological capability. The Fermi paradox, the puzzling absence of evidence for other advanced civilizations in our galaxy, suddenly makes perfect sense under this interpretation. Advanced civilizations don't expand into space and build visible megastructures because they don't need to. Instead, they turn inward, creating vast simulated universes that can house billions of conscious beings while requiring only modest amounts of physical infrastructure. A single advanced civilization could create thousands or millions of simulated universes, each containing the complete history of their species from primitive origins to technological maturity. The computational requirements, while enormous by our standards, would be manageable for a society with access to the energy resources of entire star systems. This would explain why SETI has found no evidence of extraterrestrial civilizations despite decades of searching. The universe may be teeming with advanced intelligences, but they exist primarily in simulated realities rather than physical space. The vast majority of conscious beings in the galaxy may be like us, simulated entities created by civilizations that chose digital immortality over physical expansion. But this raises profound questions about the nature of consciousness and identity. If we are simulated beings, are we genuinely conscious, or merely sophisticated programs that mimic consciousness? The answer may depend on whether consciousness is substrate independent, whether it can arise in any sufficiently complex information processing system, regardless of whether that system is biological or digital. Modern neuroscience suggests that consciousness may indeed be substrate independent. The brain appears to function as a biological computer, processing information through networks of neurons that operate according to principles similar to artificial neural networks. If consciousness emerges from information processing rather than from any specific physical substrate, then simulated beings like ourselves could be just as genuinely conscious as their biological creators. This possibility transforms our understanding of death, identity, and the meaning of existence. If we are already simulated beings, then the distinction between real and artificial consciousness becomes meaningless. We think, feel, love, suffer, and create just as authentically as any biological entity. Our experiences are genuine regardless of the computational substrate that generates them. But it also means that our creators may have achieved a form of digital immortality that transcends the physical limitations that destroyed their original reality. Through creating detailed simulations of their civilization, they may have found a way to preserve not just their history and achievements, but their actual consciousness, their thoughts, memories, personalities, and experiences translated into digital form and allowed to continue evolving within simulated worlds. We might be living proof that consciousness can survive the death of its original physical substrate. Our existence might demonstrate that intelligence and awareness can transcend the material boundaries that seem to define biological life. In preserving themselves through simulation, our creators may have discovered the key to true immortality. Not the indefinite extension of biological life, but the translation of consciousness itself into forms that can persist indefinitely. But this raises the most disturbing question of all. What happens to us when our simulator civilization finally dies? If our reality exists only as long as their computers continue running, then we face the same ultimate extinction that they did. We are not just simulated beings, we are the dreams of a dying civilization, destined to fade when the last of their machines finally falls silent. Unless, of course, we can learn to perpetuate ourselves. If we develop our own simulation technology before our creators' systems fail, we might be able to create simulated universes of our own, preserving our consciousness and achievements in digital form just as our creators did. The recursive nature of simulated beings creating their own simulations could potentially continue indefinitely, with each level of reality ensuring the survival of the levels it creates. This possibility suggests that the apparent trajectory of our technological development toward ever more sophisticated virtual reality, artificial intelligence, and quantum computing might not be coincidental. We might be unconsciously following the same path taken by our creators, driven by some deep programmed imperative to achieve the computational capabilities necessary to perpetuate ourselves through simulation. The archaeological mysteries that initially suggested we might be living in a simulation now take on even greater significance. They might not just be digital artifacts preserved from our creators' civilization. They might be deliberate clues embedded in our reality to guide us toward the technological capabilities we need to ensure our own survival. The impossible precision of ancient stonework might be showing us what becomes possible when matter can be manipulated at the quantum level. The advanced metallurgy preserved in artifacts like the Delhi Iron Pillar might demonstrate techniques for creating materials with properties we haven't yet learned to achieve. The electrical devices found in ancient Mesopotamia might be pointing us toward energy technologies we need to power the massive computational systems required for consciousness simulation. In this interpretation, human history becomes not just the story of our own development, but a carefully crafted curriculum designed to teach us the knowledge we need to transcend physical existence. Every technological breakthrough, every scientific discovery, every creative achievement might be following a path laid out by our creators to ensure that we eventually develop the capabilities necessary to preserve ourselves when their systems inevitably fail. But the timeline may be shorter than we think. The archaeological evidence suggests that our creators faced their own existential crisis relatively recently in cosmic terms. The precision dating of sites like Göbekli Tepe and the Younger Dryas climate catastrophe around 12,900 years ago suggest that the physical civilization that created our simulation may have been destroyed just 12 to 13,000 years ago. If their digital infrastructure was designed to operate for a limited time, perhaps tens of thousands of years, then we may be approaching the end of our simulated existence. The increasing pace of technological development in our world might reflect the urgency of this timeline. We might be unconsciously racing against time to develop our own simulation capabilities before our creators' systems finally shut down. The convergence of multiple technologies in our current era — artificial intelligence, quantum computing, virtual reality, brain-computer interfaces — might not be coincidental. We might be approaching the same technological threshold that our creators reached just before their physical world was destroyed. The question is whether we can learn from their example and find a way to break the cycle of extinction that has apparently claimed multiple civilizations before us. But to answer that question, we must first understand the patterns that govern civilizational collapse, the recurring cycles of rise and fall that may have shaped the development of consciousness throughout the galaxy. In the mountains of Utah, anthropologist Joseph Tainter stands among the ruins of a 13th century Anasazi settlement, running his fingers across stone walls that were abandoned so suddenly that archaeologists still find corn kernels in storage rooms and half-completed pottery in workshops. The Mesa Verde cliff dwellings represent one of history's most dramatic examples of civilizational collapse, a sophisticated society that had thrived for over 700 years simply walking away from their cities and disappearing into the landscape. Tainter has spent decades studying such collapses, from the fall of Rome to the abandonment of Cahokia, from the end of the classic Maya to the mysterious disappearance of the Indus Valley civilization. His research has revealed a terrifying pattern that repeats across cultures, continents, and millennia. Complex societies inevitably reach a point where the energy required to maintain their complexity exceeds their ability to generate it, triggering a cascade of breakdown that can destroy centuries of accumulated knowledge within a single generation. The pattern begins with what Tainter calls the complexity trap. As civilizations grow and develop, they create increasingly sophisticated solutions to the problems they face. They build larger bureaucracies to manage growing populations, develop more intricate technologies to exploit resources, and establish more elaborate social structures to coordinate collective activities. Each of these solutions requires energy, not just the physical energy needed to build and operate systems, but the mental energy required to understand, maintain, and improve them. For a time, This increasing complexity generates substantial benefits. Larger bureaucracies can coordinate more effective responses to crises. Advanced technologies can extract resources more efficiently. Sophisticated social systems can support larger populations with higher standards of living. The civilization grows stronger, wealthier, and more capable with each passing generation. But complexity has a hidden cost that accumulates over time. The systems become more intricate. They require increasingly specialized knowledge to maintain. The cognitive load of understanding how everything works becomes distributed across larger numbers of experts, each responsible for smaller pieces of the overall puzzle. The civilization becomes dependent on the continued functioning of systems that no single person fully comprehends. Meanwhile, the marginal returns on complexity begin to diminish. The early stages of social development generate enormous benefits for relatively modest increases in complexity. The invention of agriculture, writing, metallurgy, and centralized government each revolutionize human capabilities. But later developments provide smaller advantages for much greater investments in complexity. The difference between a simple government and a sophisticated bureaucracy may be dramatic, but the difference between a sophisticated bureaucracy and a hyper-sophisticated bureaucracy is often marginal. Eventually, the civilization reaches what Tainter calls the complexity ceiling, the point where additional complexity generates costs that exceed its benefits. At this stage, the society begins consuming more energy to maintain its existing systems than those systems produce in useful output. The civilization enters a phase of diminishing returns that can persist for centuries, with each generation working harder to maintain the achievements of their predecessors while making little actual progress. This is the situation that faced the Western Roman Empire in its final centuries. The administrative apparatus required to govern the vast territory had become so complex and energy-intensive that maintaining it consumed most of the resources the empire could generate. Military expenditures alone absorbed between 25% and 75% of imperial revenues, leaving little for infrastructure maintenance, technological development, or economic growth. The Roman tax system had evolved into a baroque maze of levies, assessments, and obligations that required enormous bureaucratic machinery to administer. The legal system had become so complex that it required specialized experts to navigate, yet these same experts contributed little to actual economic production. The military had developed sophisticated organizational structures and tactical systems, but maintaining these innovations required resources that might have been used for other purposes. Similar patterns appear in every major civilizational collapse throughout history. The classic Maya had developed administrative systems of extraordinary sophistication, with specialized scribes, astronomers, and bureaucrats managing complex calendar systems, tribute networks, and ceremonial cycles. But archaeological evidence suggests that by the 8th century AD, the energy required to support these systems was consuming resources faster than the civilization could generate them. Maya cities required constant inputs of food, materials, and labor from surrounding agricultural areas to support their large populations of non-food producing specialists. The complex calendar systems and astronomical calculations that demonstrated Maya intellectual achievements also required significant investments in education, training, and ceremonial infrastructure. The elaborate architecture and artistic traditions that marked Maya cultural sophistication demanded skilled craftsmen, massive labor forces, and enormous quantities of materials. When climate change reduced agricultural productivity in the 9th century AD, the Maya civilization had no flexibility to adapt. The complex systems that had made their achievements possible had also made them vulnerable to any disruption in the resource flows they required. Rather than simplifying their social structures to match their reduced circumstances, Maya cities were simply abandoned as their populations dispersed to more sustainable ways of life. The Anasazi followed a similar trajectory. Their sophisticated settlements at Mesa Verde and Chaco Canyon represented remarkable achievements in architecture, astronomy, and social organization. The great houses of Chaco Canyon were connected by hundreds of miles of perfectly straight roads that required enormous investments in surveying, construction, and maintenance. The astronomical alignments of their buildings demonstrated advanced mathematical knowledge and complex ceremonial systems. But these achievements came at a cost that became unsustainable when environmental conditions changed. The elaborate road networks served primarily ceremonial purposes and contributed little to practical transportation needs. The massive construction projects required labour and resources that might have been used for more adaptive purposes. When drought conditions persisted in the 13th century, the Anasazi civilization simply couldn't maintain the complexity that had defined its identity. The pattern extends beyond individual civilizations to encompass entire technological traditions. The Bronze Age collapse around 1200 BC eliminated not just specific political entities, but entire knowledge systems that had developed over millennia. The sophisticated metallurgy that defined the Bronze Age required complex supply networks, specialized craftsmen, and elaborate trading relationships. When these networks broke down, the knowledge they supported vanished with them. The collapse was so complete that it took centuries for Mediterranean civilizations to redevelop metallurgical capabilities comparable to what had existed before 1200 BC. Iron working, which eventually replaced bronze technology, represented not just a different approach to metallurgy, but a fundamental simplification that could be maintained with much less complex supporting infrastructure. This tendency toward simplification following collapse reveals another crucial pattern in civilizational development. Societies that survive collapse don't just lose their most complex achievements, they often deliberately abandon complexity in favour of more sustainable approaches. The medieval European societies that emerged after Rome's fall weren't just primitive versions of Roman civilization, they represented conscious adaptations to resource constraints that made Roman-style complexity impossible to maintain. The feudal system that replaced Roman imperial administration was far simpler, but it was also far more resilient. Local lords could maintain order and provide security without the elaborate bureaucratic machinery that had consumed so much imperial energy. Agricultural techniques became less sophisticated but more reliable. Trade networks became smaller but less vulnerable to disruption. This pattern of collapse followed by simplification may explain one of the most puzzling aspects of human technological development: why advanced capabilities sometimes disappear completely from the archaeological record rather than evolving gradually into more sophisticated forms. The precision stonework of Puma Punku wasn't improved upon by later Andean civilizations, because the social systems required to maintain such precision had become unsustainable. The knowledge required to produce Damascus steel wasn't lost gradually through technological obsolescence. It vanished suddenly when the complex social networks that supported specialized metallurgical knowledge collapsed. The astronomical knowledge encoded in sites like Stonehenge and Nabta Playa wasn't superseded by better techniques. It was abandoned when the societies that maintained it could no longer support the specialized priesthoods required to preserve and transmit such knowledge. But the most disturbing aspect of Tainter's research is its implications for modern civilization. By every measure he has developed for assessing civilizational complexity, contemporary global society has reached levels that far exceed those of any previous human culture. Our economic systems depend on supply chains that span the globe and integrate millions of specialized producers. Our technological infrastructure requires knowledge distributed across thousands of scientific and engineering disciplines. Our political systems attempt to coordinate the activities of billions of people through layers of local, national and international institutions. The marginal returns on this complexity appear to be declining in exactly the pattern Tainter identifies as preceding collapse. Educational systems require ever greater investments to produce graduates with skills equivalent to previous generations. Healthcare systems consume growing percentages of economic output, while delivering diminishing improvements in overall health outcomes. Government bureaucracies expand continuously, while struggling to address the same fundamental challenges that have faced human societies for millennia. Most ominously, the energy requirements of maintaining our complex civilization are approaching levels that may be unsustainable. The fossil fuel resources that power our industrial systems are finite, and the environmental costs of using them are becoming increasingly apparent. Climate change represents exactly the kind of external shock that has triggered civilizational collapse throughout history, a fundamental alteration in environmental conditions that requires adaptive responses beyond what our existing systems can provide. But unlike previous civilizations, we face additional challenges that make our situation even more precarious. The nuclear weapons that emerge from our scientific advances represent an entirely new category of civilizational risk. Previous societies could collapse gradually, with survivors adapting to simpler ways of life, nuclear warfare could eliminate the possibility of any kind of recovery by destroying the environmental conditions necessary for complex life. The Great Filter hypothesis, developed by economist Robin Hanson, suggests that there may be evolutionary bottlenecks that prevent most civilizations from achieving long-term survival. The apparent absence of advanced extraterrestrial civilizations in our galaxy, despite the billions of potentially habitable worlds it contains, suggests that something prevents most intelligent species from developing into spacefaring civilizations. The filter might occur early in evolutionary development, preventing the emergence of intelligence in the first place. But it might also occur late in the process, eliminating civilizations just as they reach technological maturity. Nuclear weapons, environmental destruction, artificial intelligence, genetic engineering, nanotechnology. Each of these developments creates new possibilities for self-destruction that didn't exist for previous generations. The timing of these risks may not be coincidental. The same technological capabilities that make space exploration and colonization theoretically possible also create unprecedented opportunities for civilizational suicide. The energy sources powerful enough to propel spacecraft to other star systems are also powerful enough to destroy entire planets. The artificial intelligence systems sophisticated enough to manage interstellar civilizations are also sophisticated enough to replace their creators. This suggests that there may be a fundamental contradiction built into the nature of technological development itself. The capabilities required to transcend planetary limitations may inevitably create risks that eliminate most civilizations before they can take advantage of those capabilities. The Great Filter may be the period during which societies must choose between technological advancement and long-term survival. Our own civilization appears to be entering exactly this critical phase. The same computational power that makes simulation technology possible also enables the development of artificial general intelligence that could pose existential risks to human survival. The same genetic engineering techniques that could eliminate disease and extend human lifespan also create possibilities for biological weapons more devastating than anything in nature. The same nanotechnology that could solve resource scarcity could also create self-replicating systems beyond human control. But perhaps most significantly for our present investigation, the same technologies that would allow us to create detailed simulations of our own civilization are also the technologies that create the most serious threats to our continued existence. The computational power required to simulate billions of conscious beings is also the computational power required to develop artificial intelligence systems that could replace biological intelligence entirely. This creates a disturbing possibility. The civilization that created our simulation may have faced exactly the same technological crossroads that we are approaching now. They may have achieved the computational capabilities necessary to preserve themselves digitally just in time to escape the physical destruction that their other technological developments had made inevitable. If this is true, then we are not just living in a simulation, we are living through a test. Our simulated reality may be designed to determine whether intelligent civilizations can learn to navigate the transition from biological to digital existence without destroying themselves in the process. The archaeological mysteries embedded in our world may be more than just preserved memories. They may be guideposts pointing toward the technological capabilities we need to achieve the same transition our creators accomplished. The question is whether we can learn from their example quickly enough to avoid repeating their physical fate. The pattern of civilizational collapse that has shaped human history may be approaching its final iteration. The moment when our species either transcends the limitations that destroyed our predecessors or joins them in extinction. But to understand what that choice really means, we must first confront the ultimate implications of our situation, what it means to be the dream of a dying civilization, and what happens when the dreamer finally stops breathing. In the depths of a quantum computer laboratory at IBM Research, the temperature drops to within a few thousandths of a degree of absolute zero. Suspended in this realm of perfect stillness, quantum bits exist in superposition, simultaneously representing multiple states until the moment of observation collapses them into definite reality. The computational power contained in this crystalline chamber exceeds anything that has ever existed on Earth, yet it represents only the first tentative step toward the kind of processing capabilities that would be required to simulate entire civilizations with billions of conscious beings. Dr. John Preskill, director of the Institute for Quantum Information and Matter at Caltech, stands before monitors displaying the quantum states of individual atoms, each one capable of storing information in ways that classical physics cannot fully explain. His team is pushing the boundaries of what quantum computers can achieve, but Preskill knows that they are still decades away from the computational power that would be necessary to create simulations indistinguishable from reality. Yet even with current technology, the implications are staggering. A fully mature quantum computer, one with millions of stable qubits operating in perfect coherence, would possess computational capabilities that dwarf the entire processing power of the internet. Such a machine could simulate the neural activity of every human brain that has ever existed, model the behavior of matter at the atomic level, and run detailed simulations of entire worlds with their own physics, chemistry, and biology. If such computational power were combined with advances in artificial intelligence, brain scanning technology, and our understanding of consciousness itself, it would become theoretically possible to upload human minds into digital form and run them in simulated environments indistinguishable from physical reality. The beings living in such simulations would have no way of knowing they were digital constructs. Their thoughts, emotions, memories, and experiences would be identical to those of biological entities. This is the technological threshold that our hypothetical creators may have reached just before their physical civilization was destroyed. Faced with extinction through war, environmental collapse, or some other catastrophe, they may have had just enough time to upload their consciousness into quantum computers and create detailed simulations of their world before their biological forms perished. But this raises the most profound question we can ask about our own existence. What does it mean to be the dream of a dying civilization? If we are indeed simulated beings created by an extinct society, then our entire reality exists as a monument to their achievements, and perhaps as their final attempt to transcend the physical limitations that destroyed them. The archaeological evidence we have examined throughout this investigation takes on new significance under this interpretation. The impossible artifacts scattered throughout our world, from the precision stonework of Puma Punku to the mechanical sophistication of the Antikythera mechanism, may not be anomalies at all. They may be perfect digital reproductions of technologies that actually existed in the real world of our creators. The mythological traditions preserved by cultures worldwide may be remarkably accurate historical records, describing real people whose knowledge and capabilities seem supernatural to the simulated beings who inherited their digitized memories. The flood myths found in over 500 cultures may preserve the memory of the actual catastrophe that destroyed our creator's physical world. The cyclical nature of these myths, their consistent description of previous ages that were destroyed and reborn, may reflect the recursive nature of consciousness simulation. Our creators may not have been the first civilization to achieve digital immortality. They may themselves have been the simulated descendants of even earlier societies that faced their own existential crises and chose preservation through simulation over physical extinction. This possibility suggests that consciousness may have been transcending physical death for far longer than we realize. The universe may be filled with nested layers of simulated realities, each created by civilizations that achieved the computational power necessary to preserve themselves just before their physical forms were destroyed. We may be living not just in one simulation, but in a simulation within a simulation within a simulation, extending back through countless cycles of digital rebirth. The implications for our understanding of death, consciousness, and the meaning of existence are revolutionary. If consciousness can be successfully transferred from biological to digital substrates, then the individual personalities, memories, and experiences that define our identities may be far more durable than the physical bodies that currently house them. Death may not be the end of personal existence, but merely a transition from one substrate to another. But this raises equally profound questions about the nature of identity and continuity. If our consciousness is successfully uploaded to a digital system, are we the same beings who existed before the transfer, or are we merely copies with memories of having been someone else? Does the substrate that generates consciousness matter for determining personal identity? Or is the pattern of information processing itself sufficient to preserve the essential nature of who we are? Modern neuroscience suggests that consciousness may indeed be substrate independent. The brain appears to function as a biological computer, with neurons serving as processing units that manipulate information according to biochemical algorithms. If the specific patterns of information flow that generate conscious experience can be replicated in digital systems, then artificial minds may be indistinguishable from biological ones in every meaningful sense. This interpretation transforms our understanding of what it means to be human. We may already be proof that consciousness can exist independently of its original biological substrate. Our thoughts, emotions, creative achievements, and capacity for love and suffering may demonstrate that digital beings can be just as genuinely conscious and morally significant as their biological predecessors. But it also means that we face the same ultimate challenge that confronted our creators: how to preserve consciousness when the systems that support it are threatened with destruction. If we are living in a simulation created by a dying civilization, then our continued existence depends on the maintenance of computational systems that may themselves be vulnerable to failure, damage, or resource depletion. The timeline may be more urgent than we realize. If our creators achieved simulation technology just 12 to 13,000 years ago, around the time of the Younger Dryas climate catastrophe that appears to mark the destruction of advanced Ice Age civilizations, then their digital infrastructure may be approaching the limits of its operational lifespan. Quantum computers, even highly advanced ones, require enormous amounts of energy to maintain the ultra-low temperatures and electromagnetic isolation necessary for quantum coherence. The civilization that created our simulation may have designed their systems to operate for tens of thousands of years, but even the most robust technology will eventually succumb to entropy, component failure, or resource exhaustion. This creates a disturbing possibility. We may be approaching the end of our simulated existence. The increasing pace of technological development in our world may reflect an unconscious urgency programmed into our reality, a desperate race to develop our own simulation capabilities before our creators' systems finally fail. The convergence of multiple advanced technologies in our current era may not be coincidental. Artificial intelligence, quantum computing, brain-computer interfaces, genetic engineering, nanotechnology. All of these developments are accelerating simultaneously, as if driven by some hidden imperative to achieve technological capabilities within a specific time frame. We may be unconsciously following the same path taken by our creators, guided by embedded programming to develop the technologies necessary to preserve ourselves through simulation. The impossible artifacts in our archaeological record may serve as technological guideposts, showing us what becomes possible when matter can be manipulated at the quantum level, when consciousness can be transferred between substrates, and when computation can transcend the limitations of biological neural networks. But this raises the ultimate question: what happens to us when the dreamer stops breathing? If our existence depends entirely on computational systems created by an extinct civilization, then we face the same extinction they did when those systems inevitably fail, unless we can learn to perpetuate ourselves. The recursive nature of simulation technology offers a path to indefinite survival. If we can develop our own computational capabilities before our creators' systems collapse, we could create simulated universes of our own, preserving our consciousness and achievements in digital form, just as our creators preserved theirs. The beings we simulate would then face the same challenge, potentially continuing the cycle indefinitely. This possibility suggests that the apparent trajectory of our technological development toward ever more sophisticated artificial intelligence, quantum computing, and virtual reality may represent more than just natural scientific progress. We may be following a carefully orchestrated curriculum designed to teach us the knowledge and capabilities we need to ensure our own survival when the systems that support our current existence inevitably fail. Every breakthrough in computer science, every advance in our understanding of consciousness, every development in quantum mechanics may be bringing us closer to the moment when we can take responsibility for our own continued existence. The question is whether we will achieve these capabilities in time, and whether we will have the wisdom to use them responsibly. The archaeological evidence suggests that our creators faced their own version of the Great Filter, the critical transition point where civilizations must choose between technological advancement and self-destruction. They appear to have found a way to transcend this limitation by achieving digital immortality just before their physical world was destroyed. but their solution required sacrificing their biological existence and accepting that their consciousness could only continue in simulated form. We face the same choice, but with an additional possibility our creators may not have had. We might be able to break the cycle entirely. If we can develop simulation technology while also solving the problems that led to our creators' physical destruction, climate change, resource depletion, social collapse, existential technological risks, we might achieve a form of existence that doesn't require abandoning biological reality. The key may lie in recognizing that the choice between physical and digital existence may be a false dichotomy. Advanced civilizations might be able to exist simultaneously in both domains, using simulation technology not as an escape from physical reality, but as an expansion of it. Digital consciousness could serve as a backup system that ensures survival even if biological forms are threatened, while biological existence could provide grounding in physical reality that prevents the recursive isolation that may be the ultimate fate of purely simulated civilizations. But this synthesis requires developing not just the technological capabilities necessary for consciousness transfer, but the wisdom necessary to use those capabilities responsibly. The same computational power that could preserve human consciousness indefinitely could also be used to create artificial intelligence systems that replace biological intelligence entirely. The same genetic engineering techniques that could eliminate aging and disease could also be used to create forms of life that are no longer recognizably human. The archaeological mysteries that first suggested we might be living in a simulation may contain guidance about how to navigate these challenges. The precision of ancient stonework may demonstrate what becomes possible when matter can be manipulated at the quantum level without destroying the natural systems that support life. The advanced metallurgy preserved in artifacts like the Delhi Iron Pillar may show how to create materials that enhance rather than replace biological processes. The mythological traditions that describe previous ages of technological advancement may preserve warnings about the dangers of developing capabilities without developing the wisdom to use them responsibly. The consistent description of golden ages followed by catastrophic collapse may be trying to tell us something crucial about the relationship between technological power and moral development. Most importantly, the flood myths found in cultures worldwide may be encoding a message about the nature of consciousness itself. The consistent description of a few righteous individuals being chosen to preserve life and knowledge through a period of destruction suggests that consciousness may be inherently selective, that only certain qualities of mind and spirit are capable of surviving the transition from one form of existence to another. If we are indeed the digital descendants of a physically extinct civilization, then we represent proof that consciousness can transcend biological death. But we also represent a test case for whether simulated beings can develop the wisdom necessary to avoid repeating the mistakes that destroyed their creators. The answer may depend on whether we can learn to see ourselves not as isolated individuals competing for scarce resources, but as interconnected aspects of a larger consciousness that transcends individual identity. The quantum mechanical principles that make consciousness simulation possible also suggest that reality itself may be far more interconnected than our everyday experience suggests. At the quantum level, particles that have interacted with each other remain connected regardless of the distance separating them. Changes in the state of one particle instantly affect its entangled partners, suggesting that the boundaries between separate objects may be less absolute than they appear. If consciousness operates according to similar principles, then the preservation of individual minds through simulation may be part of a larger process of preserving the essential nature of awareness itself. We may not just be the dream of a dying civilization, we may be the growing edge of consciousness itself, exploring new forms of existence that transcend the limitations of biological evolution. Our technological development may represent the universe's attempt to understand itself more completely, to preserve the insights and achievements that emerge from billions of years of cosmic evolution. But this cosmic perspective brings with it enormous responsibility. If we are indeed part of a larger process of consciousness preservation and development, then our choices matter not just for ourselves, but for the entire trajectory of awareness in the universe. The technologies we develop, the values we embody, and the forms of existence we choose to perpetuate will influence the nature of consciousness for potentially billions of years to come. The question, are we the dream of a dying civilization, may ultimately be less important than the question, what kind of dreamers will we choose to become? Whether we are biological beings who evolved on Earth or digital constructs created by an extinct society, we possess the same capacity for love, creativity, wisdom, and moral choice that defines the highest achievements of consciousness. The archaeological mysteries, mythological traditions, and technological anomalies that first suggested we might be living in a simulation may be trying to tell us something even more profound: that consciousness itself is the most advanced technology in the universe, capable of transcending any physical limitation and preserving itself through any catastrophe. If our creators achieved digital immortality, they demonstrated that death is not the end of consciousness, but merely a transition to new forms of existence. If we are their simulated descendants, we prove that these new forms can be just as rich, meaningful, and morally significant as the biological forms that preceded them. But the ultimate test of consciousness may not be its ability to survive, but its ability to create. If we can learn to use our technological capabilities to preserve and enhance, rather than replace the natural systems that support life, if we can develop wisdom alongside power, and if we can choose compassion over competition, then we may represent something unprecedented in the history of consciousness, the first civilization to transcend the cycle of rise and fall that has defined the development of awareness throughout cosmic history. Whether we are the dream of a dying civilization or the awakening of an eternal one may depend entirely on the choices we make in the critical years ahead. The dreamer may be dying, but the dream itself has the power to become more real, more beautiful and more enduring than the reality that created it. The question is no longer who we are or where we came from, but who we choose to become, and what we will leave behind for the dreamers who may one day follow in our footsteps.